My name is Kim Connolly. I'm the director of the Center for Global and Public Health in the College of Nursing here at Villanova University. In the session this afternoon, we're going to focus a little bit more on the disease itself of malaria. So Dr. Norman Dollahon, who is a professor of biology, is going to talk a little about the science behind malaria. I'm going to follow and talk about the application and what's happening in the field in terms of responding to malaria. And then our two guests, Benjamin Bechtolheim and Renda Kuzes, who are both from the Faith Acts Fellowship, will just give some commentary after that. We will also have some time for question and answers afterwards. So I would like to introduce Dr. Norman Dollahon from biology, who's going to tell us a little bit about the science behind malaria.
All right, let's talk about the world situation as far as malaria is concerned. Why are we gathered this afternoon? Why do we care? According to recent estimates by the World Health Organization, approximately 860,000 people die each year from malaria. So this is not an insubstantial number, and it often occurs in combination with AIDS. The overwhelming majority of these deaths are among African children, less than 5. About 250 million people are infected with malaria each year worldwide. And these are revised down somewhat by the UN from previous numbers. In Africa, malaria affects over 50 million pregnant women each year and is responsible for 10% of all maternal deaths. So this indeed is a disease that's worthy of our attention, and it's a disease that requires people of all faiths to come together to combat it. Let's look at the pathogen for just a moment. And this is going to look scary, so I'll tell you about this. Let me turn these lights down. The organisms that we're talking about are eukaryotes. That means they are nucleated pathogens. These are not bacteria, they're not viruses, they're complicated cellular organisms. They are unicellular organisms. And according to this list that I use in teaching freshman biology to some extent with modifications, these organisms are related to other organisms, some of which were photosynthetic or are photosynthetic. That means they have chloroplasts. It turns out that the Plasmodium organism actually has a plastic. It no longer is a functional chloroplast, but it plays a very critical role in their infection of humans and a wide variety of other animals. So actually malaria, Plasmodium in particular, infects everything from reptiles to birds to mammals. And humans just happen to be caught in the mix. So Plasmodium is the genus that we're going to be talking about. The major species in humans are Plasmodium vivax, Plasmodium falciparum, malariae, and ovale. And each one of these has slightly different characteristics in humans. By far and away the most dangerous is Plasmodium falciparum. And we talked about most of the deaths in Africa, they are caused by this particular parasite. This is called malignant tertian malaria for a very good reason. It is a real killer and has been for a very, very long time. Recent molecular evidence shows that this organism may have been around as long as 180,000 years. So it's something that has not been just a Johnny-come-lately in particular. Now notice at the bottom of this, I have a disturbing additional name. This is Plasmodium knowlesi. And Plasmodium knowlesi is actually a monkey malaria. We didn't know it infected humans until we were able to turn our molecular machinery to work and all of our fancy techniques like PCR and fingerprinting and so forth, that it's become very evident that this organism is a serious pathogen in places like Malaysia and other parts of Southeast Asia. It is killing people, and we didn't even know it existed in humans at all until last year. Also, another recent development is the finding that Plasmodium falciparum, the most serious of the plasmodia, is now occurring and may have been occurring in primates in Africa. this is a very serious implication, as I will point out to you, in control and our hope for eradicating malaria. Let's look at the life cycle very quickly. It is a complicated life cycle. My freshmen have to learn it, so I'm not going to give you a test at the end, but we'll do what we can with this. At the top of this picture, we see a mosquito who is sticking her proboscis into the skin of a hapless human in this particular case. Mosquitoes feed on a lot of other things too, but some species like human blood, as we can see here. And when she does that, she injects the parasite. The parasite actually in her body is in the salivary glands at this point and penetrates into the bloodstream and wanders around for about 24 hours and eventually settles, as you can see on the side of the picture over here, in the liver of the human, where it invades parenchyma cells and starts over a period of time a number of cycles, so that eventually, over a period of 5 to 16 days or so, there will be cells that contain up to 1,000 of infective stages in them. And so there's a humongous proliferation at this time. Now, there are no symptoms during this period. This is called a pre-patent period. The person does not feel particularly ill for any particular reason, but eventually that will come to a crushing halt. At the end of that 5 to 16 days or so, some of these cells will rupture open, and bursting out from these are tiny little cells, which are called merozoites. And the merozoites will have the capacity to invade red blood cells. They will enter in. I'll show you the penetration device that they have very shortly, but they can enter into red blood cells, and there they will form what are called trophozoites. These are feeding stages. What do they feed on? They feed on your hemoglobin. So they are going to be inside your red blood cells feeding on hemoglobin at this particular stage of the cycle. They will then start a process of very rapid division after they have grown to a particular size, and this is called schizogony. The nuclei, a bunch of nuclei will divide without the cytoplasm dividing, and then cells will form around each of those nuclei. At that particular point, the red blood cells will burst open. And the thing that's so devastating about malaria is that they burst open simultaneously. So all over your body, these cells reach a certain stage at approximately the same time. And when they do that, they release toxins. So the toxins include the hemozoin, which is a waste product that they produce from your hemoglobin, and they produce a lot of antigens and a lot of metabolic wastes. When these are released into the body, then we'll get the symptoms that we're going to talk about in a little bit. So this can go on for a considerable period of time, and you get pretty sick each time these things burst. So the burst is what is associated with the paroxysms, the chills, the fever that we come to think of in the old movies about malaria in particular. Now, at certain stages, and it depends on the species when this happens, some of the merozoites that invade red blood cells do not undergo this division that I described to you, but instead transform into what are called gametocytes that we see down here on the bottom of the screen. The gametocytes are either male or female, if you want to think of it that way. They're either micro, which will become the male gametocyte, or they're macrogametocytes, which will eventually become an egg. Their fate in your body is to die unless you are bitten by an Anopheles mosquito of the female persuasion. And I'll show you why that's true very shortly. If you are bitten by a female Anopheles mosquito, and she is a susceptible Anopheles, the gametocytes that she ingests will actually transform into gametes. So you'll have macro and micro gametes. And each of the microgametes will undergo what's called exflagellation. What that means is they form little sperm-like structures, so that there will be approximately 6 to 8 of those that develop from each of the gametocytes that is present. And of course, nature takes a course. What happens when you have little boy gametes and little girl gametes? Naturally, in the gut of the mosquito where they've been ingested, they will fuse to form a zygote. The zygote is like a little worm, and it can crawl between the cells of the intestinal lining of the mosquito, and they form a cyst by cellular division on the outside of the stomach wall of the mosquito. And there they undergo a rapid reduction division. So they're the only 2N stage or diploid stage is that little tiny time when that's a zygote. And those of us who are biologists will know what that means. We're 2N organisms, right? We're diploid. But they are only diploid for that tiny bit of time. Now, there's a huge proliferation. Each of those cysts will produce thousands and thousands over time and through cell division and development, thousands and thousands of sporozoites, which then again make their way to the salivary glands for their events there. Now, just very quickly, this is what a merozoite looks like. This is from the Journal of Cell Science. This is a beautiful picture, and that's why I included it for you. I just want you to see this is not a simple little pathogen. This is a honking good pathogen here we've got. You can see that this guy has a nucleus down here on this side. That's the thing that's going to divide to all the other nuclei and make more organisms. And you can see the little apicoplast up there, which is the chloroplast derivative, or the remnant up at the top. You can see they have mitochondria. And they have all these cool apical complex structures like this rock tree and these micronames, which are what enable this thing to invade the cells in the first place. Now, the sporozoite looks pretty much like this, except it's skinny. It's long and thin. So what we'd see in a mosquito would be a long, skinny version of this. Now, these are some of the forms that you would see in the blood. Up on the upper left-hand side here, these are ring forms from an actual slide of a Plasmodium Falciparum infection. I took these just the other day. You can see the nucleus looks like a little stone in a ring, and the cytoplasm is around it. So that's what Plasmodium Falciparum form we would see. The only forms we would see if I were a parasitologist studying blood, normally would be that top left and the lower right-hand side, which are the granitocytes. All the rest of the stages of Plasmodium Falciparum occur in the peripheral blood in small venules. And I'm going to explain why that's important to you here in just a moment as we go forward. But down here are the trophozoites. This is P. vivax over here. Notice those beautiful red granule stipplings that you see there. And you can see the nucleus and the cytoplasm. This is the little schizoid. This is where schizogony has occurred. And you can see a bunch of nuclei inside here. The number of those will determine which species, or we can determine which species we're dealing with. Over here, you can actually see the granitocytes, the male on the left, on my left, I guess, or no, on your left, and the female on the right at this point. Again, the nature of the disease is intermittent chills and fever associated with release of these toxic substances from infected red blood cells that have burst open. So we have these recurrent attacks or paroxysm at specific intervals. Depending on the parasite, they can be either 48 hours or 72 hours, basically. And in the case of Plasmodium Falciparum, you're so darn sick you don't notice the difference anyway. You're just sick all the time. So you don't really notice the cycle so much. One of the problems with this is severe anemia that can occur, especially with Falciparum, which can occur in horrendous numbers in the bloodstream. So we could get a lot of these organisms present. And the anemia can be a serious problem in and of itself. One thing that's very, very bad about Falciparum malaria is that a lot of times red blood cells stick together and they get destroyed in the liver and spleen, even though they're not infected. So you're in serious trouble. Also, it turns out that red blood cells cannot be produced as effectively by your body because of the release of toxic substances that can inhibit the generation of new red blood cells. Now, one thing I want to point out before I conclude here pretty quickly is that there's no sterile immunity and that you can become reinfected. And that's why vaccination is probably going to be very, very difficult. Sterile immunity means that you would be immune for life. But unfortunately, you can get bitten, you can leave an area, you can get infected again when you come back. So doesn't work that way. With P. falciparum, the added danger of coma and death which we heard mentioned earlier today, is very real. And this is because of the fact that the blood cells that are infected tend to stick out in those little capillary, post-venular capillaries, or in the capillary, after the capillaries, in the venules, sorry. And they can actually block blood flow to your brain and other parts of your body too. So they can put you into a coma, and if you don't come out, you're going to be dead. And this happens a lot in Africa. And of course, we've mentioned the danger to pregnant women and infants already. This is why a problem exists with falciparum. That's a little venule right there in the picture full of parasites. And you can see it's almost totally blocked. Now, a few more things. Relapses and recrudescences can lead to reappearance of symptoms in people who have been infected. And this is also very important in the spread of the disease. You can look healthy, you can wander off, and you can have a relapse. And when you have a relapse, then you infect the mosquitoes in the area where you've gone. A recrudescence is simply a low-level infection, and these have been known to last for 53 years in human beings. So some of these, and that's in Plasmodium malaria. So we have to watch out we don't reintroduce parasites to areas where we've cleared them out. The current belief is that malaria in the Western Hemisphere was most likely introduced by Europeans as they came over to colonize, and also by the slave trade. When they went over and got slaves to work in the areas, they brought falciparum back with them, and that's how it got here. Early historical accounts do not show it being present when Balboa tried to go across the Isthmus of Panama. Now the other victim, and I hate to say this, guys, but the mosquito's a victim too, and then I'll quit after this. Here is a mosquito that hasn't fed. There's a mosquito that has fed. Female Anopheles. Only the Anopheles carries this. Why does the female need to eat blood? Anybody know? That's because she needs it to produce eggs. So she gets infected too, and she is sick also. Now here's some pictures I took of female Anopheles mosquito from my collection. This is the female. You can see her mouth parts are nice and pointy there, so she can stick her proboscis into you and suck blood. There's the poor old male. He looks a little strange. He's got a cute little fancy set of antennae, and his mouth parts are lousy. He does not feed on blood. So he's not guilty. She is. Okay? Eggs, larvae, which live in all kinds of water from brackish to fresh water. It can be dirty water, clean water, depending on the species of mosquito. They're filter feeders. They breathe air. That's why we used to put oil on ponds to kill them. There's the pupa, also an air breather, which will metamorphose into the adult mosquito. This is where potential vectors, this is from a paper in 2004, where potential vectors of malaria and actual vectors in the past exist in the world today. So there is no malaria in the United States, but you can see that quadrimaculatus and freeborni, two species of Anopheles, are still very much here. Why don't we see malaria in all of these areas? Well, we got real handy post-World War II and did a pretty good job of knocking things down. And we did a lot to do that. And we've been very successful, but most of that success has been around the edges of malaria distribution. This is where malaria still is today. This is where malaria transmission occurs in yellow on occasion. It's not all the time. In the red, it's pretty much constant and throughout the entire region. And you can see it includes Central South America, Mexico also, Africa, lots of Africa, Sub-Saharan Africa, bad. India, the whole of Malaysia there, and down into the islands. So this is the story. I just want to leave you with this message before I turn this over to Kim. I'm probably already overdue my time, but basically, Plasmodium is more frequent today, or estimated to be in greater numbers, infection-wise, than it was in 1965, according to my very favorite textbook, which is Robertson Janvey, my old major professor. And the suggestion here is why? Because Plasmodium has become resistant, as we'll hear discussed, and what we now have to do to kill this thing. And this is a serious issue. It's continuing all the time. Mosquitoes also have developed resistance to DBT and societal issues. So I'm going to turn it over right now to Professor Kim and let her continue on.
Thank you. I think one of the reasons we talk a little bit about the science is because it ends up guiding us in the field as to what we do in response to malaria, and how, if we understand the science, then we can understand how we combat the disease. So my first question for the audience is, how many people in the room have ever been bit by a mosquito? Yeah, pretty much everybody in the room. How many of you have worried that after being bitten by a mosquito, you might die? Only a handful of people. Unfortunately, that is the reality for about 3.3 billion people in the world who live in at-risk zones. So the question is, if there is no cure currently, and there's no vaccine, what is it we can do, and what is it we are doing? And not just this sort of general we, somebody who's living and working in Africa, but what can we here at Villanova do? So the first part of the response to malaria is the treatment aspect. If somebody ends up getting malaria, there's a clinical management part to it. And there's really two parts to that. One is the diagnosis of malaria, and the other is the treatment of malaria. And in the diagnosis, there's really two ways to do that. You can do it with a microscope, which is an excellent way to do it. It tells you immediately if you have malaria. But in a lot of African countries, it's very cumbersome because it's expensive. There's a lot of parts you need to use that, and you need somebody who's specially trained to do that. So a new method that's being used is called rapid diagnostic tests, and it's a dipstick. And for those of you who are imagining that, I can't really envision that, it's like a pregnancy test. You put a little drop of blood on it, and it tells you within 15 to 20 minutes if someone has malaria. Why is it important to diagnose properly? As Dr. Dollahon said, one of the symptoms is fever, and so a lot of times in areas where malaria is endemic, if somebody comes in with a fever, the automatic assumption is, oh my gosh, they must have malaria. But if you start treating everybody who comes in with a fever as malaria, and you start handing out medicines, then quite quickly that medicine is going to become resistant, which, as he pointed out, will then just continue the cycle of malaria. So you really want to have good diagnosis so that you can treat someone properly. Plus, if they don't have malaria, you want to find out what they do have so you can give them the proper medication. The second part in the clinical management is the actual treatment of medicines. And in the past, a lot of what was done was monotherapy. And that simply translates into somebody was given one medicine to treat the malaria. And I'm sure a lot of you have been sick. You've probably had to take antibiotics or some other medication. And the doctor usually tells you to take it for 7 or 10 days. That's quite a long time to take a medicine, especially when usually around day 3 or 4, you start feeling healthy, and so sometimes you stop taking the medicine. The new therapies in malaria, it's 2 medicines that you get. They're combination medicines. They're based on a Chinese medicine, and essentially, because it's a more powerful medicine, you can take it for a shorter amount of time. So most of the therapies these days are for about 3 days. And so people will take that right around when they start feeling better. They already have all the medicine in them. As Dr. Dollahon said, malaria is it's deadly. Within the first onset of symptoms, people can die within 24 hours. And I know that our guests this afternoon, if you heard them in the Falvey Library, talked a lot about that. They can also slip into a coma. So one of the best ways to do this is to look at preventing malaria. And right now, currently, that is the best way to help reduce the burden. And there's 3 ways that are really done to prevent malaria. The first is prophylaxis medicine. The second is something called indoor residual spraying. And the third one is mosquito nets. So for the prophylaxis, has anyone here ever traveled to an area that's where malaria is? Yeah, did anyone take medicine before going? Or were you given it by your doctors? I see a lot of heads nodding. Exactly. So in this case, there's 2 groups that tend to get targeted for preventative medicine, and that's you all in the audience who don't normally live in an area where there is malaria that's endemic. Your doctor usually gives you some medicine so that you can take it before you go, while you're there visiting the country or working, and then when you come back. The second group that's targeted, and this goes back to a little bit of the science, is pregnant women who live in areas where malaria is endemic. When a woman becomes pregnant, because of everything that's happening with her body, she loses a little bit of that immunity that Dr. Dollahon talked about that you can build up a little. And because of that, pregnant women are more susceptible to malaria. What happens then is they're more at risk for dying, at risk for having miscarriages, high rates of anemia, or having babies who are born prematurely, or having babies who are born with low birth rates. And for anyone, if you know anything about maternal or child health, if a child is born prematurely or if they have a low birth rate, then that can cause a lot of problems for them in the future as they grow. So if you can, the current therapy for that is when a pregnant woman comes in for her visits, you give them medicine, and it's usually 2 doses throughout the 9 months of pregnancy to really prevent that woman from getting malaria while she is pregnant. The second form of prevention that's used a lot of is indoor residual spraying. How many of you have ever used mosquito repellent or bug spray around your house to kill anything? Yeah, I see a lot of hands, a lot of heads nodding. Imagine spraying that inside your house, and more specifically, inside your bedroom. This is essentially what indoor residual spraying is. They take a spray and they'll spray it inside a home, and the idea is that that lovely photo that you saw where after the mosquito feeds and she's really big and heavy and she needs to kind of take a break, she sits on the wall, usually, where that mosquito repellent has been sprayed, and she'll die. So it doesn't prevent someone from being bitten, but it does prevent then the malaria from being transmitted between one person to the next person. So this is quite an effective way. The common spray that's used is DDT, which for some of you may think, hey, wait a minute, we don't really use that too much here in the United States. But internationally, it is the recommended insecticide by the World Health Organization. One of the downsides is that you need to spray about 80% of the households in the area that you're working in, and it only lasts for about 3 or 6 months. So after that point in time, you need to respray. But this is something that's done a lot, especially in refugee camps or areas where there's a concentration of people. So I'm sure if you've seen images on television of either Indonesia after the tsunami or any refugee camps in Africa, this is a very common technique. But one of the most effective ways to prevent malaria, and this is certainly a way that Villanova can contribute, in fact, that Villanova has been contributing this week, is in terms of using nets, and specifically insecticide-treated nets. And what that means is that all that insecticide that we spray on us here to keep the mosquitoes off, or they spray in the houses, it's actually embedded within the net itself. And then that net is distributed to different communities, and then it prevents the mosquito from actually biting someone. And that's really one of the most effective ways that you can prevent malaria, and that's something that we can currently do here. I don't know how many of you actually went out today near the Oreo and or over the week and bought one of these little bracelets or contributed to the Nothing But Nets. But essentially the money that you were contributing to that organization was raising money to buy mosquito nets so that they can make it out to the populations that need it. One of the things in the science is that he talked a lot about how it affects the body, how women and children tend to be, they're a more vulnerable group. And so when you get into the field and you're distributing nets and you don't have enough, say there's 100 people in the community but you've got 10 nets, you have to make decisions about who you're going to prioritize with. And based on the science, the decision usually is that you target first children under 5 and pregnant women. And if you can target those groups, you're targeting the more vulnerable groups that there are. Now certainly today's theme is world religion. And I don't know, were any of you at the 3 o'clock talk in the library? Some people? Well, one of the themes for today is world religions. And the question was, how do religions play a part in combating malaria? Now, in working overseas and in all these intervention pieces, one of the best ways that religions play a piece is that you work with the religious communities, whether it's the religious leaders or churches or synagogues or mosques, whatever it is. And if you can tap into that network of the religious leaders, then you can really have a great communication system. And you can use that from everything from saying, we're going to be having a mosquito net distribution on Thursday. Could you please announce it in your churches? And so one of the aspects of today being World Religion Day was looking at how do different religious organizations, how can they help in combating malaria? And this is sort of how it all comes together. Understanding the science tells us how we can actually do the best interventions on the ground, and understanding those interventions, then using resources that are on the ground, such as faith-based agencies, to make that all happen, to help reduce the burden of malaria. And there was a report released just yesterday by the Rollback Malaria Initiative that said we are making progress, And we're making progress because of these 3 key components in preventing malaria. And it basically said, you know, if you can raise $1,000, you're going to protect about 380 kids a year from malaria. And I think that's a great statistic, but it's also just sort of very concrete for us here at Villanova, who were contributing this campaign of buying nets, to realize that, you know, you can make a very a big impact by just contributing a little amount of money. And so for those of you who are thinking, oh, really, I don't know about that, I think there's a great quote, and we're going to be hearing from a guest speaker, I believe, who will be showing up in a few minutes to talk a little about that. But there's a quote by Anita Roddick that says, if you think you're too small to have an impact, try going to bed with a mosquito. So just something to consider. We have some time for either questions or response from our 2 guests, Benjamin and Brenda, thank you, who work for the Faith Acts Foundation, who have done a lot of work with different faith groups talking about how religious groups have responded to malaria. So perhaps if the 2 of you want to talk for about 5 minutes. I think we have a slightly different group than we're in the library.
So just quickly, I think it's really special that you're at a university that has sort of science and religion played out in the same conversation. I think it's really important. And I think faith communities and civil society in general have a really big role to play in exactly the interventions that were just spoken about. So just quickly as sort of an example, in 2003 there was an attempted vaccine campaign for polio in Nigeria. And in the implementation of the polio vaccine rollout, there were a group of Muslim religious leaders in the north that hadn't been consulted when people in their communities were being vaccinated, saw sort of public health teams coming into these communities and vaccinating, and then released statements saying that the vaccinations would transmit HIV/AIDS, would kill young children, would make women sterile, things like this. So sort of misinformation about this public health campaign. That misinformation meant that people weren't getting vaccines, that there was in fact an outbreak, and just like with the indoor residual spraying or with any of these sort of public health interventions, you need sort of a critical mass of adoptees in order for it to actually be effective. So what happened was that there was an outbreak of polio that actually spread to neighboring communities. Now the response to that was that 2 very popular, very well-known religious leaders in Nigeria came out, and 2 Muslim leaders came out and spoke against it and said, in consultation with the Ministry of Health, said that in fact the intervention didn't have any dubious purposes, was in fact to cure polio, and they publicly got the vaccines themselves and had their own children vaccinated. And it was them stepping up, and this was the Sultan of Sokoto, so a high sultan, a spiritual Muslim leader for millions of Muslims in Nigeria, as well as the Emir of Kano, so another eminent Muslim leader in one town in northern Nigeria. And these 2 people came out, got the vaccines themselves, had their children vaccinated, and this was what caused the uproar over this vaccine to die down. So it's one thing to know what the intervention is. It's one thing to know that we need bed nets on the ground, that we need indoor residual spraying, to know how ACT treatment works. And it's another thing to make sure that people are actually getting these treatments. So bed nets are an amazing, amazing tool in the battle against malaria, but they're only as good and as much as they're used. So having faith leaders across the country standing up in front of their congregations and speaking about how to properly use a net, how to treat a net, the importance of sleeping under a net every night, and also couching this within a religious framework and a theological framework is really, really important and really, really powerful. So it might seem disjointed to think about faith and science or faith and public health in the same sort of conversation, but I think it's really, really important. So I think I'll pass it over to Brenda.
So we're going to share with you what you can do as part of this movement. So Benjamin and I last year were on the Faith Acts Fellowship, which is a joint program between the Interfaith Youth Corps and the Tony Blair Faith Foundation. And the goal of the program was to bring young people of different faiths together. So they chose 30 young people from the US, the UK, and Canada, and make them vanguards of to talk about their faith traditions and how that calls them to service, and also to make them ambassadors for the Millennium Development Goals. So the specific focus was malaria. The program consisted of training in the UK to talk about what why do we need to learn about different faiths? Why is religious literacy important? And then we went on to different countries in Africa. I was in Mali, Benjamin was in Malawi. And in Mali, Malawi, and the third country was Tanzania, we did training on the ground. We understood how these faith communities work together to basically try to eradicate malaria from their communities, try to bring health initiatives to their congregations. I was with an organization called Project Muso, and I remember sitting in a circle with an imam and a pastor and the rest of our group, and we asked them, why do you guys work together? How has it been so easy for you when, sometimes back home we have such a hard time bringing faiths together and working together? We said, you know what, we need to work together, we need to survive. None of that stuff matters, none of the little details matters. And it's important that we work together. And it was so simple, just hearing him talk about it. Yeah, we definitely need to work together. And Project Muso was an NGO on the ground in Bamako, which is the capital of Mali, and it served over 26,000 people. And it served them through their religious communities, through building a health clinic in that part of town. And it was very successful. And we just got to study with them on the ground and learn from that example. And then we went back to Chicago and decided how we were going to reach out to our local communities. We were all placed with different host organizations on the ground. I was placed with the Malaria Policy Center in Washington, D.C., and Benjamin was with the Center for Interfaith Action on Global Poverty. And what strategy were we going to design to reach out to local faith communities and young people who are interested in this type of work? So it was interesting to see the contrast of faith communities on the ground in different parts of Africa, and also faith communities back home in the U.S. that work together to raise money for nets, to do advocacy. For example, the Muslim community in the United States launched a giant campaign called United We Stand, I think. I don't remember the exact name of the campaign, but it reached out to thousands and thousands of Muslims in the U.S. to tell them that, you know what, in sub-Saharan Africa, 90% of deaths that occur from malaria are in sub-Saharan Africa, and we can do something about it. So it was interesting to see them connect the local to the global, and these were people of different faith communities. And it speaks out to this verse in the Quran that says, if you have saved one person, it's as if you've saved all of mankind, similar to the saying in the Jewish tradition. So they were taking these calls to service, these different calls and different traditions, and using them to mobilize people for the good. And so the Faith Sacks Fellowship connected 30 young people in the US, the UK, and Canada to these messages and to these communities. And I think the interesting part about it is that they're repeating the fellowship next year. So they're taking applications now, and I wanted to tell you about it because I think we've met so many amazing students from Villanova, and you guys would be great if you'd be interested in the fellowship. And I know Kathy does have some applications, or does have some more information, and you can get in touch with any of us to get more information or to apply. And I just wanted to share with you a really inspiring quote that one of the young people here, Bridget, who is the class president here at Villanova, gave Benjamin and I. And it says, I'm only one, but I am only one, and I cannot do everything, but I can do something. And I will not let what I cannot do interfere with what I can do. So just starting from that premise, we all understand that we are capable of mobilizing others to do good, of doing good ourselves, and of understanding what the needs in our community are and trying to meet them. So the Tony Blair Faith Foundation Interfaith Youth Corps Fellowship was a great chance for Benjamin and I to sort of focus on multi-faith action and focus on the Millennium Development Goals, specifically malaria. So if you have any more questions about that, feel free to reach out to any of us.
I suppose just one final note thinking about combating malaria in terms of faith is that you've all chosen to come to Villanova University, which is a Catholic university. And I don't know if any of you have really looked at or talked about in your theology courses, but the mission of the university is built on that idea of service to others and really reaching out and helping those who are more vulnerable. And certainly in any of the initiatives in combating malaria is definitely one way to do that. So it's just sort of something to think about and trying to link something very concrete in combating malaria with how does my faith play into that. I think at this point in time, I'd like to introduce Bridget Halligan. Bridget. She's not here.
She's back there.
Bridget,
where are you? This is Linda Kamali. Linda, would you mind going up and saying certain things? Bridget is playing with Kathy.
thinking we had a dream.
Yeah.
We had just sort of looped a lot of this together. We have sort of a special guest, and I'm going to introduce Bridget, who is, as it was pointed out, the president of the Student Government Association, and she's going to introduce our guests and just talk a little bit why they're here and how they connect with the day.
Hi, I'm Bridget. I'm the president of Student Government, and our first philanthropy project was to raise money for this organization called Nothing But Nets. And I'm actually going to introduce this 9-year-old from the area named Catherine, who this is kind of her philanthropy project too. She inspired us. Kathy Overturn from campus ministry told us about Catherine and her mom, and we were so inspired that we decided to do it too. And so Catherine, do you want to talk about it? And Catherine and mom. So yeah, I'll introduce Catherine and her mom, and I'll have them tell you all about it because they're the experts here. They are our inspiration. So this is what we have been raising money for these first couple weeks back at school. Yeah.
Hi everybody, how are you guys? My name is Linda Connolly, and this is my daughter, Catherine. I wish I could have been here all day. This sounds like it just would have been an extraordinary day, especially to see you guys again. 2 years ago, we were together in Washington, D.C. for World Malaria Day. But I just want to give you just a little glimpse of how my family got involved in this. I love the quote that you gave about you can't be too small to have an impact. Because that mosquito and my daughter are the perfect example. 4 years ago, actually over 4 years ago now, almost 5, I watched this program on malaria on our local PBS station, and I was just completely distraught by what I had learned about malaria. The statistics that you've heard all day, every 30 seconds a child dies from malaria. The next morning at breakfast, Catherine was 5, and I was just sharing with them what I had learned, and I also have another child as well who's now 7. But I was sharing with them what I had learned, and I was explaining to Catherine about these mosquitoes in sub-Saharan Africa and how they carry these bad germs, and it's really, really, really sad for the children, and they need these nets. And Catherine asked me, well, Mommy, do they die from these mosquitoes? And I said, they do. Every time we count to 30, a child dies. And she sat there, and what'd you do?
Counted to 30.
Yeah, she sat there. I was looking at her fingers, and she got to 30 and did it 3 times and just looked at me, and she said, tell me more about these nets, Mom, because we're going to send them to Africa right now. And I really was overwhelmed by her wanting to do this. So we went to our church. We are members of Hopewell United Methodist Church in Downingtown, Pennsylvania. And Catherine marched into our director of children's ministries and said, I want to send some mosquito nets to Africa. The kids really need them. They said, all right, let's do it. And 5 years old, in 1 weekend, she raised over $1,000 just by teaching about mosquito nets. Just like you guys said, teaching is so incredibly important. Teaching about these mosquitoes that carry bad germs, and teaching about these nets that save lives. So, Catherine, how old are you now? 9 years old. How much have you raised so far?
Over $150,000.
Over $150,000. That's a lot of nets. Did you ever think you'd raise that much money? No. I have to tell you, when we hit $10,000, I seriously thought I was going to die. Like, I thought, how did she get to $10,000? I never would have believed that she could have this kind of impact. Some of the things that she does, teaching. We've been to over 50 churches. Whenever a pastor or a priest or a minister or a layperson hears about our story and says, will you come and share it? We almost always say yes. If we're able to make it on a Sunday or a Saturday or whenever they need us, we always try to do it. It's so basic. It's so easy to understand. We always talk about the 5 words. If you can teach anyone about Africa, bed nets, mosquitoes, and malaria, they understand this story. They get this. Little children get this. They completely understand how important this net is. And that's ultimately what Catherine did. So what had happened was she had raised about $1,000. At the same time, the Nothing But Nets organization was kind of being born through the United Nations Foundation. They had heard about what Catherine was doing, and they gave us a call, and the director there spoke with Catherine and said, Catherine, I heard all the great work that you've been doing. Do you think maybe you would be a spokesperson and help us out with some things for Nothing But Nets? And what'd you say? Sure. I only do AM kindergarten. I have all afternoon Essentially, that was her thought process, and that's what happened. And now 4 years later, she's raised over $150,000. She has taught countless people all about these mosquito nets and how important they are. The United Nations Foundation credits her for over $2 million that has come in over the past 4 years. You've been on a lot of stuff. You've been on CNN, you've been on the New York Times, you've been on the news, Time for Kids, such cool stuff. Do you think it's pretty cool, or you're just like, yeah, I'm just doing it? What do you think? Yeah. For Catherine, it really is about helping those kids. It's about, why don't they have a net when they need one, Mom? This just doesn't make sense to me. Those are kind of the things that Catherine has always said. This just doesn't make sense. They need them, we need to send them. And a $10 bill, even to Catherine, to my 9-year-old, who's starting to really learn the love of money now, she understands that that $10 bill can really save a life. This past October, Catherine and I were invited to Uganda for a net distribution trip. I just went on my own. Originally, Catherine was going to go, but when I learned more about the conditions of the parts of Uganda that I was going to be in, I went to refugee camps and internally displaced people camps. It just wasn't suitable to take her. You were okay with it? You were okay with it. She said, just email me every day. Tell me how many nets you sent. Tell me how many you're going to give out tomorrow. Do your job, Mom. Get it done. Catherine is a very, as a matter of fact, kid. She just wants this done. And that's what I did. I was able to distribute about 2,500 of Catherine's nets throughout Uganda. And I was in a situation, like you said, where you're in a camp, you're given 500 nets to distribute, you've got about 5,000 people staring at you. You have to pick and choose. It was awful. We had to choose between in particular camp, it was just pregnant mothers. But a really special thing happened. One of Catherine's favorite stories is about a little baby. What's her name?
Priscilla.
Priscilla. Do you remember Priscilla's story? How early was she born? At 21 weeks? Or I'm sorry, 31 weeks? 31 weeks, do you remember that? It's been a year since we talked about this, forgive us. I met this mom and this baby who, the baby was born at 31 weeks gestation, and she was under 4 pounds when I met her, born in a camp with no electricity and no running water. Just her surviving the birth was a miracle, truly a miracle, which I praise God for at that moment, because this baby was just so tiny. I was not permitted to give her a net because the mother was no longer pregnant. We were just had to do pregnant mothers. And I had a little protest. I was just devastated by this. And I knew Catherine would say, Mom, you're not leaving this baby without a net. There's absolutely no way. I could hear her voice. And I sat and waited for translators and just went over and over and said, this baby must have a net. I'm not leaving until, like, I will go down the street and buy a net somewhere if we can't give one of hers. And what happened?
She got a net.
She got a net. And the most amazing part was about 6 months after my visit, one of the women that I was with got the chance to go back to that camp. And she sent me a picture of baby Priscilla, and how wonderful is she looking. What did we love about her picture? Didn't she look so healthy? She was actually chubby and healthy. And she, 6 months plus now, no malaria. She's not had it, and she's using that net. So these nets can go such a long way, and it's just so extraordinary. And to be able to come here and share with you, if you think, oh, I can't really do that much, what can I do? You can just share this story. Ultimately, that's what it's about. It's about teaching your friends and thanking God that this isn't something you have to worry about, but not forgetting, especially with your faith and with humanity, that this is very, very real for families all up over Africa. Every night that I went to bed, I tucked my net in fiercely because I could hear the mosquitoes hitting the wall. It was terrifying. It was very real. And it brought it back to my heart as a mom and just as a human being, why this is so incredibly important. Villanova University, I mean, this is just extraordinary. The abilities that you have with your professors and with your friends and your families, you could really do some extraordinary things. So thank you so much for letting us be a part of it. And the Millennium Development Goals. The hope is that by 2015, malaria is at near eradication. Catherine, about 2.5 years ago, we were at the Clinton Global Initiative, and Catherine did some work with President Clinton. And what did you say there to everybody?
We work really, really hard. We can end it by 2014.
Yeah. So everyone's deciding 2015 is our date. Catherine said, you know, I think if we work really, 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 really hard, we could get this thing done by 2014. And do you still believe that now? She's kind of on the fence. She's thinking, well, maybe we'll take it into 2015. But at that time when she said that, we just were dumbfounded, the group of us that were there. And Catherine's example of humanity and just determination to get this done, I find it so inspiring. And now, you know, what started out as Catherine is now a whole family project, and especially after being in Africa and distributing medicine and holding these precious lives in my hands while they were losing their life to this disease, it only fuels you more. So I encourage you to step up, to rise up. It's about spirituality, prayer, and action, and taking those steps, especially throughout your university, and just running with them, because you can do some awesome things. And we live less than an hour away. If you need resources, please call on us. We're here to help. We want to end this by 2014. No later than 2015. We've got things to do. She'll be in high school by then, so plan out.
So we at Villanova were so inspired that we had to help you. So we didn't know what to do. And we made bracelets out of tools. So like it looks like a net. And we've been selling them around campus now for about a week and a half. And today was our last day. And so we have an estimate. We don't have our final numbers in yet. But we wanted to present you with a check. And it's made out to you because we know that we trust you with it. We want you to do what you think is right.
We're not going to this.
Yeah, sorry. Catherine and I were just talking out in the lobby about all of our favorite things, and we were talking about the new Harry Potter world. And I said, okay, well, I'm giving you a check. You know, it says nothing but nets on it, but so Catherine, we'd like to present you with this check for $1,500 right now, and we'll see where it goes from there. This is for you. And for you personally, because I know that all of the money, it does go to the next. We have a little present for you. It's a little bracelet, and on it, it says, I cannot do everything, but I can do something. Or no, sorry. No, that's not what it says. It starts with it says, I am only one, but I am one. I cannot do everything, but I can do something. And I will not let what I cannot do interfere with what I can do. This is for you. We want you to wear it for free. Show it. You're welcome. So thank you. Thank you. You inspired all of us here.
Villanova. Pretty good. This is our third university, and every university, at the end, she says, this is where I want to go to college. So first was St. Joseph's University. I'm afraid to say it. My alma mater, and she was determined this is where I'm going to school. And then this past April, where did we go? We were at Penn. That was her determination. So are you afraid to say it now? What do you think? You're on the fence? Tell me later.
Yeah. Right. Well, thank you very much. Thank you.
Well, we're just following up. Are there any questions for any of our guests, whether it's, I know, Catherine and her mom, or Dr. Dollahon, myself, or our visitors from the Faith Act Fellowship?
Dr. Dollahon, you mentioned that the students within the world is DBT.
Yes.
Is there anyone from Kansas you have information? Does this? Sorry, I have a cold. Are we moving on to different pesticides, or are we moving away from what was it? Indoor residual spray altogether? Or?
Well, certainly it would be good if we could find some alternatives to DDT. DDT has environmental issues associated with it, but it's still the insecticide of choice. But since World War II, there's been developing resistance to DDT on the part of a lot of insects. And so I think we're going to have to find some alternatives. As I understand it, the bed nets are actually impregnated with pyrethrums. You've seen the Johnson & Johnson family ads for their natural products. One of the things they do is it in Africa, they have them raising flowers from which they get the herbivores. And certainly that is a much less toxic substance, but I'm afraid even at that, we have to watch, because organisms are there to survive, and built into them are all kind of genetic mechanisms that enable them to develop resistance. The malarias are doing it. We've done it in response to malarias. Something that's very interesting are the genetic changes in human populations that have occurred or have been encouraged by the presence of malaria. For example, Africans lacked Duffy blood group antigens. They have FY minus, whereas most of the rest of the world has FYA or FYB. The Plasmodium vivax malaria uses those antigens to enter cells. They actually attach. So here's somewhere where a human population has changed. Think of sickle cell anemia, beta thalassemia. There are a lot of other instances where humans have actually, their genetic constitution has actually been altered somewhat, or at least the frequency of genes, because of the parasites. So who's shaping whom here? You know, are we selecting for the parasites, or are they selecting for us? That's a question we can ask ourselves. But there's
I'm going to
lot
be a parasite here and get these two. But continue with the questions. They have to make.
I know they have to make an exit. So.
Thank you so much.
Thank you all.
Thank
But
you.
keep the conversation